Windows 764, 6 gig memory, and this is the normal Far Cry 2 game. We're using the Far Cry 2 benchmarking tool, and we're setting it to ultra settings, 19 by 12 resolution. We have 16 times anisotropic filtering enabled in the driver to force that, and so it's 90 by 12, 4x, DirectX 10, ultra settings, which is a very common setting for benchmarking for displays. GeForce GTX 285 versus a GF100 card. So we're running it 2 times per session, and we just start the benchmarking on both. So it will take a few seconds to load it. And we are running the range small benchmark, which is basically the standard way to benchmark Far Cry 2 at a very popular resolution. So nothing special in here. Let's just see. Yeah, get some sound in here. So as you can see in the frame rate already here, there's a pretty significant difference in the frame rate. So we are way over 100 in the beginning. Here we are in the 50s. So that was the first one. We're running it the second time. As usual, as normal in benchmarking, you need to run it multiple times to get a reproducible scores. Again, here the frame rate way, way higher than GTX 285. That's the reason why you have to run it multiple times. Okay, so the benchmark results over here, where you can see about 84 frames per second on average on a GF100 versus, okay, let's take the first one, because this one had a stutter, is about 50.6. So it's 50.6 versus 84.12 performance difference of GF100 versus a GTX 285. So this is just the normal standard rate Far Cry 2 benchmarking. Okay. So the next demo I want to show is, let's get it out of here. So the other is dark void physics. So dark void is having a physics benchmark. And we show the difference in, so you learn in the session the difference in performance and physics performance between GT200 and G400. So shall we start here? So this is creating a typical physics node with all the particles. So it was a gunfight chosen here because you have a lot of particles and physics effects going on. And this is to create a kind of high physics node for benchmark. This is not about the you have the most iconic fight in here in the game, but you have a pretty compelling physics load here. You get all these particle effects here. Yeah.
Floating around.
So the result here in GT200 is about 38 frames per second. It is again 19:12 resolution, 4xa and 16af, and you get here about 77 frames per second. So it's all one GPU running physics and graphics out of one GPU.
So this benefits from a couple of things. Obviously, it's great graphics performance, but it also benefits from the increase in physics performance. One of the other things which we didn't really talk about that much is one of the things which GF100 is much better than previous is switching between computing and graphics modes. It's been called context switching. It's roughly 10 times faster, that switch. And when you're doing graphics and computing on the same GPU in a game, in the Dark Void example, you're switching between rendering and doing physical simulations. That switch cost is much better here, which is another thing that this benefits from. Ultimately, this will also benefit from concurrent kernels when we get to something like PhysX 3.0. But as you can see, it's already more than twice as fast.
So the last performance numbers we're showing is a ray tracing demo, the NVIDIA RTD. So I show it here again on the started first on the GT200, GTX 385. You got the frame counter and set it to full screen. Same over here. So after a few sample counts, you will see it runs at about 0.2 frames at a second here on the GT200, where on a GF100 you get 0.6 frames per second. That makes it 3 times faster, a good piece of 3 times faster in ray tracing over GT200. You can already see it visually that here the picture is much more done already than on the GT200, which makes a huge difference.
So this is benefiting both from the increased core count. Of course, there's 512 cores compared to 240 on a GTX 285. It also benefits quite substantially from the caching architecture. So one of the things about ray tracing, of course, is you're shooting rays into a scene and then they bounce. When you have unpredictable behavior for something, it's really nice to have a cache. Whereas if you have really predictable access patterns, what you actually want is programmer-controlled shared memory. But with unpredictable behavior, what you want is good caching performance and behavior. And with L1 and L2 true read-write caches and in large amounts of them, you get really nice speedups for these kinds of computations. So this is an example of kind of computational performance advantage between GTX 285 and GF100.
So also, it's much more responsive on GF100. Yeah, got below the desk.
That's right. This is one. Were you inside the car there?
Yeah. But that is one of the things that it is much more responsive on GF100. That makes it much more easier to navigate as well. So the speed up is really significant. Okay.